In our last assignment, we saw that we could use Pythagorean's theorem to solve a right triangle. If you knew two sides, you could figure out what the third side are. In this lesson, we look at a 45, 45, 90 triangle. This is one of the special right triangles we'll be looking at. And you'll see that we can find missing sides even if we only know one side length. We can find the other two. Anytime that you're solving a missing length in a 45, 45, 90 triangle, you're going to label it like this, then refer to your formula chart. See below. Here's our formula chart, what it would look like on a formula chart. And here's our 45, 45, 90 triangle. It's called that because we have two 45-degree angles, and of course the right angle, the 90-degree angle, to make it a special right triangle. When you have two angles that are the same in a triangle, there's two sides that are the same, and it is the legs on the right triangle. This leg equals this. Of course, the hypotenuse is the longest side. Remember, it's the two sides that make the right angle that are the legs, and they're equal on a 45, 45, 90 triangle. Now here's how you label these. You're going to label the legs, since they're the same, X. If one is X, the other is X. They're the same size. The hypotenuse, this formula tells you you're going to take whatever this X number is and multiply it times the square root of 2. It's called X square roots of 2. That's how you find the length of this hypotenuse if you know X. If you know the length of the leg, you multiply it times the square root of 2 and you get the hypotenuse. So let's take a look at an example. It says find the lengths of the missing sides. You can see this side is the only one we know. It's 5. So the first thing you do is label these sides like it said in the formula. This side with 5 is X. And I go ahead and put X equals, because it equals this side, it equals 5. This other side we have here, whoops, I can get rid of the wrong one, but that's okay. It is also X, so it's the same as this X, it equals 5. Then over here we have X square roots of 2, which means take X and multiply it times the square root of 2. But we already know X is 5, so we're going to take 5 times the square root of 2. We put that in the calculator, and we get approximately, we'll round to the nearest tenth, and we'll do that in all our problems. So 5 times the square root of 2 is 7.1. So again, we started off with this side was 5, so this other leg has to be 5. This side was labeled X times the square root of 2, just like it says in the formula chart. So we take this number for X and substitute it in there. So we get 5 square roots of 2, or 5 times the square root of 2. You can put it in your calculator just like that. You don't even have to put the time sign. And we round to the nearest tenth and get 7.1. So this side AB, this other leg, was 5. And the hypotenuse side AC was 5 square roots of 2, or approximately 7.1. Let's look at the quick check. So again, let's see, this time we've got the hypotenuse. We label our sides. This side is X. Don't know what it is yet. This side is also X. Same as this, but we don't know what it is. And this one was X times the square root of 2. And I put the equal sign in here. It equals this number right here. Okay? And this is an equation we're going to solve for X. So we do it over here. We write that equation. X, and this means times the square root of 2 equals 4. So since this is multiplication, to undo and get rid of this square root of 2, we divide by it. So right here, all this does was cancel out. And we get what we're solving for, an X. So we take our calculator and take 4 divided by the square root of 2, not just 2, but the square root of 2. And that should round to about 2.8. Okay? You should do your calculator check, make sure you can get this answer. So this x right here was 2.8. Of course, this other side is the same, 2.8. So side AB, 2.8. Side BC, both the legs, 2.8. Pretty easy to do when you just label it like it says in the formula chart. X square roots of 2. If this is the side we know, then it gives us the equation right there. In the other example, we knew the leg, so all we had to do was substitute it in here, and we knew the other leg was the same. Pretty easy problems. Let me know if you have any questions, though. We'll just run through some examples some more. Example 2. This time we were given a funny side here, starting off with a square root. This side here, the hypotenuse is 3 times the square root of 15. So again, you do the same thing. Okay, this side is x, this side is x. We don't know what they are. This side, we know what it is, so we're going to put that equal sign in and get us a nice equation here to solve for x. So we'll write it over here and we'll solve it. Just like the last one, to get x by itself, all you have to do is divide by this, what we're multiplying. This is x times the square root of 2, so to get rid of square root of 2, we divide by it. This just cancels out. And we get x equals this ugly thing divided by the square root of 2. So you punch in your calculator 3 square roots of 15 divided by the square root of 2. Try it with your calculator now. And this rounds to the nearest tenth, 8.2. So now we know x equals 8.2. This side is x, so it's 8.2. This side is also x, so it's 8.2. Our two answers. Again, if you need to pause the video, go ahead and take notes. If you got any questions, let me know. Here, this time we've got this leg is 2 times the square root of 3. Right? Label our side. This side is an x, so we know that x equals 2 times the square root of 3. This side is x also, so we know, yeah, it's the same as this one, so we know this side is 2 times the square root of 3. So BC is 2 times the square root of 3, or about 3.5. Now this side, of course, is our x times the square root of 2. So let's do it over here. What's x times, well, x is 2 times the square root of 3. And then we've got to multiply that times the square root of 2. We just substituted this in for x. Now we multiply. It says take x times the square root of 2. Here it is. And so you do that with your calculator just like this. Put in 2 square roots of 3, and I use parentheses for times. You can use just the time sign if you want, and then times the square root of 2. Should definitely try that with your calculator. Make sure you can get this answer. It rounds to about 4.9. So we know this side is 4.9, or AC is 4.9. Please definitely try that with your calculator. Make sure you're getting these answers. If you need some help, let me know. Example 3, nothing new here. We're given this side is 7. Label the sides. This is one of the legs. These two sides that make the right angle are the legs. They're labeled x. This side is x2, so we know it's the same as this one. So we know BC already is 7. This one is whatever x is times the square root of 2, so we'll substitute that x number in now. In place of x, we put 7, and then times the square root of 2, which rounds to about 9.9. That's all there is to this special right triangle. 45, 45, 90 triangle. Do a little quick check here. So this time we got the hypotenuse is 4. So this side is x. We don't know what it is yet. And this is x. We don't know what it is. And this one is x square roots of 2. And it equals this 4 right here. So here's our equation. We'll solve it. Again, we're gonna, since it's multiplication, we'll divide by the square root of 2 to get x by itself. It cancels out that square root of 2 there, and we get x. In your calculator, you're going to put in 4 divided by the square root of 2. Try it. And that rounds to about 2.8. So x equals 2.8, so this side's 2.8, that side's 2.8, and we've got them right here. Example 4, given this side, label them, that's the x side, equals 2.3. This is an x side, we know it's the same as this one, 2.3, so we've already found BC. And this side equals x times the square root of 2, so we're going to substitute that 2.3 in for x. And we get 2.3 times the square root of 2, which is approximately 3.3. Pretty easy stuff. Now this was a note earlier on your page. If you look at the first page, it says the triangle formed by two consecutive sides of a square and its diagonal is 45, 45, 90 triangle. What it's trying to say here, complicated as it may sound, is that if you draw a triangle, the diagonal here, it splits it up into two 45, 45, 90 triangles. This cuts this 90 degree in half, and this angle becomes 45. And of course, if this one's 45, this one has to be 45, so these three angles add up to 180. And of course, you can see in a square, two sides are the same, so yeah, of course, whenever two sides are the same in a right triangle, those angles are going to be 45, 45 also. So a little example of this would be something like this problem right here you don't have on your page, so you might want to copy this down on the back or wherever you can find it. If you had a square and its side was 10, so then all the sides are 10, of course, and you wanted to find the length of the diagonal of the square, we can use these properties we learned about 45, 45, 90 triangles. So again, let's see, we'll look at this bottom one right here and find this length of diagonal. Of course, this side would be labeled x. So with this one, where we're not trying to find it, these two sides would be the same. So x equals 10, and this side, the diagonal or the hypotenuse, would be x times the square root of 2. So we're going to substitute that 10 in for x into the x square root of 2, and we get 10 times the square root of 2, which is approximately 14.1. There you have it, 45, 45, 90, a special right triangle. We'll look at another special right triangle in the next lesson. Go ahead and work on your practice now. If you have any questions, let me know. Pretty easy stuff.